One day all the stars will go out, black holes will evaporate, and time itself will lose its meaning. Scientists know at least 5 ways in which everything that exists could perish. Ready to find out which one is the most terrifying and beautiful? Then make yourself comfortable. Imagine a huge cup of freshly brewed tea. At first, it's hot, steam rises in a column, but gradually it cools down until it reaches room temperature. That's exactly how, only on a gigantic scale, our universe will die. Scientists call this process the heat death or the big freeze. And this is one of the most likely scenarios for the end of everything that exists. The thing is, the universe, like your tea, strives for a state of equilibrium. Right now, we have hot stars and cold space, but over time this difference will even out. Energy will be distributed evenly, like sugar completely dissolved in water. Stars, these giant cosmic batteries, will exhaust their fuel one by one. First, the massive blue giants will extinguish, then sun-like stars, and finally, even the most resilient red dwarfs will go out after hundreds of trillions of years. After this, the universe will plunge into darkness. Galaxies, once shining with billions of stars, will turn into a graveyard of black holes, neutron stars, and cold planets. But this is not the end of the story. Even black holes, those insatiable devourers of matter, will eventually evaporate due to Hawking radiation. This process will take an unimaginably long time, a number with 100 zeros, but ultimately, they too will disappear. What will remain? A handful of elementary particles scattered across the vast expanses of an infinitely expanding universe. The temperature everywhere will approach absolute zero, minus 273 degrees Celsius, colder than the most powerful freezer. In such a universe, there will be no sources of energy left, no temperature differences, nothing interesting will happen. This will be the true end of time. After all, to measure time, changes are needed, and there will be nothing left to change. Interestingly, this scenario directly follows from the second law of thermodynamics, which states that entropy, or the measure of disorder, in the universe can only increase. When the universe reaches a state of maximum entropy, all processes will stop. No new stars, no galaxies, no life. Only infinite, evenly distributed energy, too dispersed to do anything. But there's no need to worry too much about this. All these processes will stretch over time scales that the human mind simply cannot comprehend. We still have trillions of years of relatively comfortable existence ahead of us. And who knows, by that time our distant descendants might find a way to outsmart the laws of physics or move to another universe. And the heat death is not the only possible end, but just one of several scenarios that we will discuss in the following chapters. Upbeat music. Imagine you're holding a piece of chewing gum. At first, it stretches gently, then it becomes thinner. And then, bam! It snaps, leaving sticky traces on your fingers. Now multiply that by trillions, and you'll understand what the Big Rip is, the most spectacular end of the universe one could imagine. It all started with an astonishing discovery made by astronomers in the late 90s. It turned out that galaxies are not just moving apart, but accelerating, as if someone invisible is blowing into the sails of the universe. Scientists named this invisible wind dark energy. It behaves like the most troublesome bully in the class. The more space expands, the more dark energy pushes it apart. If this process continues, in a few tens of billions of years, we are in for a real cosmic show. First, the distant galaxies will disappear, not because they will vanish, but because the space between us and them will stretch faster than the speed of light. Then our galaxy, the Milky Way, will start to fall apart. Stars will scatter in different directions, like confetti at a New Year's party. But the most terrifying part will begin in the final moments. Imagine that all the forces of nature suddenly decided to quit. First, gravity and stars fly apart in different directions, then electromagnetism and atoms lose their electrons. Eventually, even atomic nuclei can't withstand it. Protons and neutrons break down into quarks. It's like taking your phone apart first into components, then into microchips, and finally into individual atoms. Why is it called a tear? Because space-time itself stretches too quickly, as if you draw two dots on a balloon and then inflate it with a pump so fast that the rubber can't withstand it. Only in the case of the universe, the rubber is the very fabric of reality. When could this happen? According to the most terrifying predictions, in 50 billion years. That's 3.5 times the current age of the universe. But there is good news too. A few months before the end, we will definitely know what awaits us. However, there will be nothing to be happy about. An hour before the finale, the solar system will be torn apart, a minute before the Earth, and a second before the end, your body. But don't rush to hide in a bunker. Perhaps dark energy will weaken over time or disappear altogether. In the meantime, enjoy the fact that your molecules are still holding together, the stars are shining, and the universe remains intact and unharmed. You blow up a balloon, and then suddenly let it go. It deflates with a noise, darts around the room, and eventually hangs limply like a rag. Now imagine that instead of a balloon, it's our entire universe. And instead of your hands, it's the relentless force of gravity. That's what you call the Big Crunch. This is a scenario where the universe suddenly decides to stop expanding and gathers all its things back into a singularity. It all started with a simple question: what if dark energy suddenly runs out? Or what if gravity turns out to be stronger than we thought? Then the expansion of the universe will gradually slow down, stop, and bam! Start going in the opposite direction. Galaxies that are currently moving apart will suddenly be drawn towards each other, like iron filings to a magnet. At first, it will even look beautiful. The night sky will become much brighter because galaxies will start colliding and merging. However, there won't be much time to enjoy it. A few billion years after the compression begins, the temperature of the universe will start to rise. At first, it will be unnoticeable, then faster and faster, like an oven that someone is gradually turning up. In the final moments before the end, the following will happen. Stars will start colliding so frequently that the night sky will be brighter than the day. The temperature will rise to millions of degrees. No planets will survive. Atoms will begin to disintegrate under the monstrous pressure. All the matter in the universe will compress into a point smaller than the head of a pin. This will be the complete opposite of the Big Bang. Scientists call this the Big Crunch. And yes, this is the only scenario where the universe will literally not have a single free electron left. Why is it called a compression? Because space will be shrinking from all sides at once. Imagine you are in an elevator with mirrored walls. The closer the walls, the more reflections you see. Only in the case of the universe, the walls will be compressing from all sides simultaneously, and instead of reflections, there will be colliding galaxies. When could this happen? If it does happen, it will be very far in the future, in hundreds of billions of years. But there is one interesting point. If the Big Crunch really begins, time for observers inside the universe will seem to accelerate. The last millions of years will fly by like minutes, the last seconds like moments. But don't rush to become cosmic pessimists. It's possible that this will never happen. Current data shows that the expansion of the universe is more likely accelerating rather than slowing down. So for now, you can sleep peacefully. Your atoms will stay in place. Galaxies will continue to spread out, and the universe is not planning to close up shop just yet. However, if you suddenly notice at night that the stars have become somehow brighter than usual, maybe it's worth starting to worry? In any case, we will find out about this not very soon. In the meantime, enjoy the vastness of our expanding universe. Here you are living in a cozy wooden house, built on the slope of a volcano. Every day you drink tea, admiring the view from the window, without even suspecting that the foundation of your house is a thin crust over bubbling magma. This is exactly how our universe exists, in a state of false vacuum. It seems stable, but at any moment, everything could go to smithereens. The point is that our reality might not be the most stable version of the universe. Physicists believe that there could be more reliable vacuum states where the laws of physics work differently. And if somewhere in the depths of space a quantum fluctuation occurs, that's when particles suddenly appear out of nothing. Thanks to quantum mechanics, a catastrophe of cosmic scale could begin. The process will develop rapidly. In a random point in space, a microscopic bubble of new vacuum will form, smaller than an atom. But this tiny bubble will start to expand at the speed of light, ruthlessly rewriting the laws of physics in its path. Inside it, matter will behave in a completely new way. Electrons might become heavier than protons. Gravity might disappear entirely, or forces we are not even aware of might emerge. The boundary of this bubble will be like the wall of apocalypse. Everything it touches will instantly cease to exist in the form we know. Stars, planets, and even more, atoms themselves will disintegrate and reassemble, according to new rules. And the scariest part is, we won't get any warning. 1 millisecond you're calmly watching a video on YouTube. The next, and your eyes can no longer perceive Light, because photons will behave completely differently. Why do scientists call our state a false vacuum? Because we might be in a kind of energy pit, like a ball stuck on a small ledge of a cliff. It seems stable, but just a small push, and it will fall off, down to a more stable state. Only in our case, the ball is our entire reality, and the bottom is a completely different physics, where the existence of matter as we know it might be impossible. When could this happen? Theoretically, it could happen at any moment. But don't rush to panic. The probability is extremely low. Much less likely than winning the lottery jackpot 10 times in a row. Although, as they say, someone has to be that lucky person on whose eyes reality itself will reboot. It's interesting that this scenario resembles a computer game where suddenly everything changes. The rules. Only, unlike a game, there won't be an option to restart the level. If vacuum decay begins, the process will become irreversible. The new version of reality will spread in all directions at the speed of light, leaving no chance for escape. But there is good news. It's possible that our vacuum is already in the most stable state, and there's no need to worry about anything. Even if that's not the case, the process could take an unimaginably long time, trillions of years. By that time, humanity will either have long since disappeared, or if it survives, it will have figured out how to detect the threat in advance or even prevent it. So for now, you can sleep peacefully. Your atoms remain in place, and the laws of physics continue to work, and the vacuum isn't planning to play a cruel joke on us. But if suddenly tomorrow you wake up and find that water has suddenly become thick, like honey, and the stars in the sky are behaving strangely, it might be worth starting to write your memoirs. Who knows, they might survive the reboot of reality. Have you ever had the experience where you look at the last ember in a dying fire? It no longer warms, only occasionally flickers with tiny sparks until it finally turns into cold ash. Let's imagine that instead of a fire, it's our universe, and instead of embers, the last remnants of matter and energy. This is quantum death, the slowest, quiet, and melancholic end of all possible ones. Let's start with the fact that even in the emptiest regions of space, a strange thing constantly happens. Pairs of particles are born and disappear. It's as if in an absolutely empty room, dust particles suddenly appeared and then vanished immediately. Physicists call this vacuum quantum fluctuations. But over time, these last manifestations of activity will fade away. Let's trace how exactly this will happen. First, all the stars will disappear. Even the longest living red dwarfs will extinguish after trillions of years. Then the remaining planets and asteroids will begin to disintegrate. They will simply be torn apart by the expanding space. Black holes, these last cans of the universe, will evaporate due to Hawking. This process will take an incredibly long time. Imagine a number with 100 zeros. That's approximately how many years it will take. What will remain in the end? A handful of elementary particles scattered at such distances that they will never be able to interact with each other. Photons stretch to incredible wavelengths, and quantum foam the tiniest bubbles of space-time, constantly changing their structure. The temperature throughout the universe will equal absolute zero, minus 273 degrees Celsius, colder than the frostiest corners of our galaxy. Why is this called quantum death? Because in such a universe, nothing will remain that could change or occur. Time will lose its meaning, as it requires events to be measured. And there will be no more events. It's as if all the clocks in the world stopped, and there was no one left to wind them. When will this happen? So far into the future that all numbers lose. Meaning, if you started counting the seconds until that moment right now, you wouldn't have enough of the universe's entire lifespan to even count to a billionth of a percent. But there is good news. By that time, humanity will either have learned to exist under such conditions or will have disappeared. The most astonishing thing about this scenario is the complete lack of drama. No explosions, no ruptures, no loud effects. Just a slow, steady fading of everything that ever existed. The universe will quietly turn off the lights and leave, not even leaving a note saying, "Sorry, we're closing." But there's no need to be sad. We still have trillions of years ahead. And who knows, maybe our distant descendants will find a way to outsmart even quantum death? After all, if we were able to understand these complex things, then we can also deal with their consequences. In the meantime, let's appreciate the fact that we are living in a golden age when the universe is still full of energy, movement, and life. We have come all the way. From the Big Bang to quantum death. It's frightening, interesting, and a little sad. But the good news is that humanity still has plenty of time to find a way to save itself or create a new universe. If you enjoyed this journey into the future, give it a like and subscribe to the channel. There are many more amazing topics about space, science, and the mysteries of the universe ahead. And what kind of end of the universe impressed you the most? Write in the comments. Let's discuss. And don't forget to share the video with your friends. Let them ponder the eternal as well. See you again in the boundless realms of science.